Welcome back everyone. So in our previous lecture we saw how to build a predictive model using linear regression, and the model was not performing very well, and we understand that, but we want to see how to also develop a predictive model using other methods or underlying mechanism. Now remember that in our previous lectures we explained that we apply a linear regression when our outcome or dependent variable is a continuous variable. For example, height, weight, price, all these are continuous variables where you can have any number possible, 1, 2, 2, 5, 2, 6, right? So any number possible is continuous variable, and we go with a linear regression. When we have a binary outcome, for example, yes, no, male, female, then superhost, in this particular example, non-superhost, only two categories. This is called a binary variable. When our output or dependent variable is a binary variable, we do not apply a linear regression. We explained it earlier that in this particular case, a linear regression is not a very suitable model. All right. So in this particular example, we are going to see how to apply a logistic regression and build a logistic regression based predictor. I'm going to move a little faster because the initial steps are pretty similar. So I'm going to just do it real quick. I'm going to copy it from here, these nodes. You know how to bring those, and I'm going to keep it here. So these are the same stuff: reading the CSV file, getting rid of any missing values, or applying a column filter to get rid of any unwanted column, and then finally making a partition of our data. All right, so the next step, let's first configure our data. Let's configure and read the correct data. Here we have our trained data file. Let's apply, click OK. Let's run this one. For missing values, what to do, you can say again remove row if it finds a missing value for any data type. So these are the three data types: either it's a floating number, the continuous number, or integer, full number, 1, 2, 3, 4, 5 count values. So whatever type of variable it is, if it finds a missing value, it is simply going to remove that row. Click apply, click OK. Let's run this one. Apply a column filter here. Now which column to remove? Well, see that the superhost S and superhost N basically are the same columns, right? So the superhost S is the one that we need. Superhost N is not the one that we need. So basically we are keeping the string column, the same column also available as numeric 1010. We are removing this one because we want to keep the string one. KNIME can handle the string column, so it is completely fine. Let's apply, and now we have our data that does not include this superhost numeric column. All right, let's apply the column partitioner again. 80%. You can also change it to 70%. I'm just going to keep it 80% for training, 20% for testing. Let's run this one. And now the next step is to, because again our dependent variable superhost non-superhost is a binary variable, so we are going to apply a logistic regression. Let's search for logistic regression, and remember that first we need a learner, next we need a predictor. So connect the learner like earlier, configure the learner. What is your target column? Superhost S. Reference category, anyone, it will be automatically selected. Just simply click apply, click OK, and let's run this one. Now it will show you that the algorithm did not reach convergence. In our last week's lecture, I already showed you how to get rid of this one. Simply select this one to iteratively reweighted list square and click apply, click OK. Let's rerun this one, and now it is ready for our next phase. The learner is ready. All right, so let's bring the predictor. The predictor is already available here. Let's connect, and remember that the predictor always will be connected using that square to square. Let's configure this one. We don't have to really make any changes here. Let's click OK, and we need our test evaluation data, not the test data, rather the 20% data that we left for evaluation. All right, now you can run and bring the numeric scorer, search for a scorer. Let's bring the scorer here, connect these two using the arrow. Before doing that, before running the scorer, let's take a look at the table right here. Open output, second option, go to table, and you can see at the very end you have your actual column and the predicted column. Now see that in most of the cases, so the first two it predicted correctly, but for the third one, the actual value was non-superhost, but the model predicted superhost. So not necessary that the model will be perfect. I told you all earlier as well, but it is much better. All right, let's configure the scorer. What are your columns? Superhost is your reference column. Predicted superhost is your predicted column. Let's apply, click OK. Let's run this one. All right, and now you can see basically the confusion matrix here. So the confusion matrix will show you how the model predicted and the actual numbers of that category. You can see here, and the accuracy statistics, you can also see the accuracy statistics here. The accuracy was 0.805, that means almost 80% prediction. And the other metrics, you can also see the precision, recall, sensitivity, specificity. So I'm going to not spend too much time again on these matrices. Please be familiar with these. These are the matrices that you will use for evaluating your model, and pay special attention to, of course, the accuracy here. The accuracy will tell you how accurate your model is predicting. So it's not too bad, like 80% accuracy in your model. It's fair. It's not super good. It's not too bad. All right. Finally, you can also see all of those right here by right clicking. Go to output, go to table, that will give you the confusion matrix again, the superhost and non-superhost, and how the model predicted superhost to non-superhost. All right. You can also see by right clicking the same matrix accuracy table that I showed earlier. You can also see it here. You can see right there the accuracy for the model is 80.5%. So you can get all these values also by right clicking your scorer right here. All right, so that was a quick introduction to building a logistic regression based predictor, and this is how you can do it. You can also bring your test data like earlier. Let's bring our test data. Let's read the CSV, get rid of these columns. Let's put it right here. We saw this portion, and now from here what you can do is we can simply do a predictor and a scorer. All right, so let's do a prediction and do scoring. So if we go back to connect our learner to this new predictor here and connect this column filter to our data, the only change that we need to make is creating the new data for test. Read this one, apply, click OK. Let's read this one, train a test data, apply the missing value as before. Column filter, yes, we don't want the numeric column superhost, and get rid of this one. It is because we brought it from here. It is already set to our desired settings. And now provide this new test data to your predictor. Remember that this predictor is not the same this one. It is going to use the learner, but it is going to use this new data, test data. Let's configure this one. We don't have to make any changes. Let's click OK. Let's run this one. And finally, now configure your scorer, if see if everything is correct, everything is in order. Let's run this one, and now see your accuracy statistics for your test data. All right, before, remember the 20% data, for the 20% data the accuracy was almost 80% or more than 80%. But see, when you provided the new test data or unknown data, the accuracy is now only 52%. So this is very common. That means your model actually understood the pattern very well with your original data, but now when you gave it unknown data, now it is making more error, and this is very common again. So this is why we have to separate out our evaluation data and then use this one that the model did not see before for an actual evaluation. All right, so this is how we can build a logistic regression based predictor and do our prediction using a new set of data. I hope this is helpful. Please let me know if you have any questions. Thank you.